Here's a quick overview of test number 3 for 463-663 modern controls. This is a take-home test due next Sunday. Individual effort, meaning no working together, no using check, no using AI. The goal is to take a double and control a double pendulum. So this is a double pendulum simulation. I want to have a step response that is between 0 and 6 seconds. Come on, puppy dog. Has less than 10% overshoot in the step response, and ability to track a constant set point, and reject a constant disturbance. So like this would be a bad step response. For your exam, turn in a block diagram of your plant and controller, the MATLAB code used to determine your control law, the resulting control law, a step response with a constant set point, constant disturbance. For the linear system, a step response to the nonlinear system, kind of what I was showing you there, and the main calling routine used to generate the step response. Now you've got a couple different options. If you just want to shoot for 80 points, assume there's no noise, all states are measured for full state feedback, constant set point, and a constant disturbance. But note, you need to use all three inputs. You have the input of force on the base, you've got the input of torque 1, and the input of torque 2. So I need to design a controller with 3 different inputs. If you want to shoot for B level, 80 points, you can assume no noise. However, in this case, only the position and angles are measured, not the velocities. To get the velocities, you'll need a full order observer, constant set point, and no disturbance. And finally, at the A level, assume no noise, only positions, angles measured. So again, you need a full order observer, constant set point, and a constant disturbance. So this test is due Sunday at midnight. It can be submitted on Blackboard. That's test number 3.